Three scenarios every project manager dreads, and every one of them is playing out on job sites around the world right now. The budget explodes in the final stretch of construction. A critical deadline is missed with no early warning. A key subcontractor goes completely dark. These are not hypothetical risks. Globally, approximately 80% of large-scale construction projects exceed their initial budgets, and roughly 60% fail to meet their original delivery dates, a pattern that has persisted for decades across every market and every project type. Yet the world's leading architecture and engineering firms are already solving these exact problems with AI, tools that forecast schedule bottlenecks before they materialize, systems that surface cost overruns in real time, algorithms that translate risk into a clear, actionable number rather than a gut feeling. Today, we take a hard look at the current reality of AI-powered construction project management, what it actually does, who is using it, and what it means for your practice. If you work in construction or architecture, this scene will be painfully familiar. Dozens of spreadsheet files with no single source of truth. Group chats on messaging apps where critical decisions get buried. A site supervisor's handwritten notebook that no one else can read. This is the project management reality for the majority of small and mid-sized firms in 2024. Not in one country, but across the global industry. The problem is not a shortage of information. The problem is too much information, scattered across too many disconnected places. When a design change comes in, the cost estimate doesn't catch up in time. When the schedule shifts, material orders get tangled. The moment one person in the chain misses a critical update, the whole sequence collapses, like dominoes. According to McKinsey Global Institute analysis, the construction sector ranks as the second least digitized industry across the entire economy, behind only agriculture. Construction productivity growth has stalled for decades, while manufacturing and financial services have surged forward. This gap, between where construction still operates and where digital tools have already arrived, is precisely the opening that AI is now moving into. So what exactly does an AI project management tool do in a construction context? The capabilities fall into three core pillars. The first is schedule forecasting. An AI trained on hundreds of historical projects synthesizes current work progress rates, weather data, and labor deployment figures to issue early warnings well before a delay becomes visible to the human team. For example, flagging that a structural steel phase will hit a capacity bottleneck in 23 days based on current crew velocity and supplier lead times. The second pillar is real-time cost monitoring. The system continuously analyzes purchase orders, contracts, and even site photographs, detecting early signs of budget drift and surfacing them as clear numbers and trend graphs, giving teams the chance to intervene before a small variance becomes a serious overrun. The third pillar is risk scoring. By synthesizing contract conditions, weather forecasts, and subcontractor performance history, the AI assigns every active project a risk score between 0 and 100. Crucially, this exposure can be measured and acted on at the design stage, before a single column is poured. Let's compare the AI project management platforms currently gaining traction in the global construction market. First, Oracle Primavera Cloud. Built for large-scale contractors and program owners, its core strengths are AI-powered schedule optimization and resource demand forecasting across complex, multi-phase programs. Second, Procore. The platform's AI automatically classifies site photos, RFIs, and change orders, with firms reporting an average 34% improvement in cost forecast accuracy following adoption. Third, Autodesk Construction Cloud. Its defining capability is deep BIM integration. When the design model changes, the schedule and budget recalculate automatically, closing the gap between design intent and field execution. Firms that adopted AI-assisted design and construction tools in combination with BIM have reported a 42% reduction in design error rates. Fourth, regional and compliance-focused platforms. Across different markets, specialized tools have emerged that embed local building codes, procurement regulations, and subcontractor structures directly into the AI logic, making them highly practical for mid-sized firms navigating complex local regulatory environments. The critical differentiators across all of these tools are BIM integration depth and the quality of mobile field support. Choosing the right platform depends on your firm's scale, existing workflows, and the types of projects you run. How do you actually bring these tools into your firm? For teams who find the prospect overwhelming, here is a concrete, stage-by-stage roadmap. Step 1. Audit your existing data assets. Determine where your historical project schedules, cost estimates, and final settlement records are stored, and in what condition. I cannot learn without data. And this inventory is the foundation that everything else depends on. Step 2. Select a pilot project. Before committing to firm-wide adoption, apply the tool to one mid-scale project first. This gives your team the space to internalize a new workflow without the pressure of a critical deadline. Step 3. Configure BIM integration. This is the step that unlocks the sharpest jump in AI prediction accuracy. When your design model and your project management platform are connected, every design change automatically propagates through schedules and budgets. Firms that combine AI tools with BIM integration have reported reducing manual coordination time by over 70%. Step 4. Establish real-time mobile field reporting. I can only make real-time decisions if it receives real-time data. Structured mobile reporting on site, photo logs, daily progress inputs, issue flags, is what keeps the AI's predictions grounded in what is actually happening. Step 5. Institutionalize a monthly AI report review. No platform, however powerful, creates value unless your team regularly interprets the outputs and feeds the insights into real decisions. One structured review meeting per month is the minimum needed to build that discipline. What kind of measurable change do firms actually see after adopting these tools? Industry research tracking architecture and construction firms that used AI project management platforms for 6 months or more reveals consistent patterns across geographies. Average on-time project delivery rates rose from approximately 58% before adoption to 81% after, a 23 percentage point improvement that directly impacts client relationships and repeat business. The frequency of budget overrun events dropped by roughly 47%. Perhaps the most striking finding involves project managers themselves. Administrative workload fell from an average of 18 hours per week to 7 hours per week. Those recovered 11 hours per manager per week shifted directly into design review, client communication, and the kind of strategic problem solving that actually requires human judgment. In documented cases, mid-sized design and construction firms reported that AI-assisted project coordination enabled them to handle approximately 2.3 times more concurrent projects without adding headcount. The compounding effect is significant. More projects running simultaneously, fewer errors across all of them, and team members spending the majority of their time on the work only they can do. I will not replace the architect's intuition or the experienced project manager's judgment. It cannot, and that will remain true for the foreseeable future. But in the domain of repetitive data tracking, early warning detection, contract analysis, and administrative processing, AI is already faster and more consistent than any human team working alone. The model taking shape across the global construction industry is a clear division of labor. AI reads the numbers. Humans create the value. Firms that adopt these tools today are not simply gaining short-term efficiency. They are accumulating project data, learning from every build, and compounding an advantage that firms waiting 3 years to start will find very difficult to close. The difference between an early mover and a late adopter will not be measured in 3 years of experience. It will feel like 10. Here is the question worth sitting with. In your firm right now, which forecast is most consistently wrong? Schedule, cost, or people? The answer points directly to where I should enter your workflow first.